Let's continue with the endocrine system. And today we're talking about the parathyroid gland. So we have got four parathyroid glands. As you can see, this is the neck, the front of the neck. We have got the thyroid gland. And just at the back of the thyroid gland. So the thyroid gland has got two lobes, the left and the right connected at the isthmus. So each thyroid gland has got two parathyroid glands, one down, one on top. So there are four in number, and the total weight is about 150 milligrams. Okay. So what do these parathyroid glands make? They make what is known as a parathyroid hormone. So we'll talk about now the hormone, but before then, these parathyroid glands, as we have seen, they are embedded in the superior pole or the thyroid and also in the inferior pole, and each one of these glands will measure 3 by 6 by 2 millimeters. And then they have got two types of cells. The first type of cell that these glands have are the chief cells, and these chief cells contain a lot of prominent Golgi apparatus and endoplasmic reticulum. And these guys are involved in protein synthesis, isn't it? So therefore the chief cells have got also secretory granules, and these organelles that we can see will synthesize and secrete parathyroid hormone. So if they ask where is the parathyroid hormone secreted or synthesized, it is in the parathyroid gland, but specifically by the chief cells. There are also oxyfuel cells in the parathyroid gland, but these are less in number. They contain oxyfuel granules and a lot of mitochondria in the cytoplasm. They increase in number as we get to grow, but their function is that unknown. Okay, so you can see also the blood supply. The same arteries which are supplying the thyroid gland is also supplying these. You can see the inferior thyroid artery. Okay, you also have, of course, the superior thyroid on top. So how do these guys produce their hormone? Remember, they produce parathyroid hormone. So what happens that when the calcium in the blood reduces, the parathyroid glands will secrete the parathyroid hormone. The work of the parathyroid hormone is basically to increase calcium in the blood. So when the parathyroid hormone secretion increases, that is going to be an increase of the parathyroid hormone in blood. And so, what the parathyroid hormone is going to do is it will go to the kidney and also to the bone. In the bone, it will increase the resorption of bone. Resorption basically means you are more like breaking down the bone. As you get to break down the bone, you are doing, because when you are making the bone, is calcium is needed to make it hard. So you are removing that calcium, or that is known as bone resorption. But not necessarily breaking it. Think of you are removing a bit of bone. You are trying to decrease it. The way you have got a house, you will not really break the house, but you can go with a knife and then start removing some soil, right? That is how resorption is. So when you resolve bone, you are going to increase now calcium in the blood, because that calcium you are removing from bone will go into blood, and that is going to restore now the normal plasma concentration of calcium. The parathyroid hormone can also go to the kidney. In the kidney, what it can do two things. One, it can increase calcium reabsorption. Remember the kidney, what does the kidney do? The kidney, what happens that when blood goes to the kidney, it is the kidney makes urine. So a lot of the things which are found in blood will be removed from the blood and it will go into urine. But what is going to happen is that what is needed again will be removed from the urine, taken back into blood. So what happens? The calcium that was in the urine will be removed from the urine and taken back into blood. That is calcium reabsorption. Right, and then when that happens, if you have reabsorbed calcium, it means that you are going to have little calcium for you to excrete, to urinate. All right, and that still will restore calcium. Besides that, in the kidney what happens that when there is parathyroid hormone, the parathyroid hormone is going to stimulate the production of 1,25 dihydrocholecalciferol. So this guy is going to be produced, the 1,25 dihydroxycholecalciferol or 1,25 dihydroxy D3. And what this 1,25 dihydrocholecalciferol does is that it is going to increase 1,25 dihydrocholecalciferol in blood. Remember, we have increased the production because it's the kidney that forms the 1,25 dihydrocholecalciferol. So when the kidney forms more of it, it means that it will now increase in blood. And what the 1,25 dihydrocholecalciferol or 1,25 dihydro D D3 does is that it will go now to the intestines, and in the intestine it will tell the intestines, hey intestines, can you absorb more of calcium? When you eat food, any calcium that is in the food, it will be absorbed, and that's how you get to increase calcium. So this is basically the function of the parathyroid hormone. The parathyroid hormone has got 84 amino acids. We already know it's made by the chief cells, and you know the action on the bone and on the kidney, right? Now, how do you control the secretion of the parathyroid hormone? So there is also what is known as a negative feedback. So what will happen is this: in conditions like hypocalcemia, when you have got low calcium, or hypomagnesemia, when you have got low magnesium, this will stimulate the production of parathyroid hormone. Okay. So the opposite, which is hypermagnesemia and hypercalcemia, will inhibit the production of this hormone. So what is going to happen is that an exception in the case of severe hypomagnesemia is associated with chronic magnesium depletion, like when someone takes alcohol, that inhibits parathyroid synthesis. Remember, when you have got low magnesium, it's supposed to increase the production of parathyroid hormone. But when you take alcohol and there is too much, there is severe hypomagnesemia. That is, instead of stimulating the production of parathyroid hormone, it will inhibit the production of the parathyroid hormone, the storage, and also the secretion will be inhibited. So low calcium is going to be sensed by what is known as a calcium sensing receptor, which are found on the parathyroid gland. This calcium sensing receptor will now stimulate the production or the release of parathyroid hormone, which acts on the kidney, on the intestine, and on the bone to increase calcium. When you have got increased calcium, that increased calcium is now going to go and inhibit the calcium sensing receptors from causing the release of parathyroid hormone, because we don't want it to be more, right? So how does this work? What is the mechanism of action of the parathyroid hormone? So when there's an increase, when there is an extracellular calcium sensing receptor, okay, remember the calcium sensing receptor, what it does is that it will respond, it will be able to notice the decrease in calcium in blood. So the calcium sensing receptor is a G protein coupled receptor, and we already talked about how G protein coupled receptors work. And is that going to do? Is this calcium sensing receptor is present on the chief cells of the parathyroid gland, also the thyroid C cells which produce calcitonin, and also on the kidney. All right, these are the three regions. So most of the classical cellular action of parathyroid hormone is mediated by the CMP mechanism, which is linked to adenylyl cyclase. So what happens that when the parathyroid hormone attaches to the cell where it's supposed to act, it is going to activate the G protein. The G protein, specifically the GS, now is going to be activated. The alpha subunit is going to move and activate adenylyl cyclase, which will convert ATP to CMP. CMP is going to activate protein kinase A, which is going to lead to phosphorylation of your protein. And when you phosphorylate protein, then that is now going to lead to the actual function that you want. Remember the three actions, either on the kidney or on the bone. So this is what is happening. When the calcium decreases, it stimulates the production of the parathyroid hormone. That stimulates the bone to increase bone resorption. The kidney, then it is going to increase calcium reabsorption, and the increase in urinary CAMP. what the kidney will also do is that it is going to decrease phosphate reabsorption. It's opposite. When calcium is reabsorbed, phosphate is going to be removed. That leads to phosphat phosphaturia. That's the excretion of phosphate in urine. On the intestines also, you are going to increase calcium absorption. Okay, indirect via 1,25 dihydrocholecalciferol, which is produced by the kidney. So meaning that parathyroid hormone has got effect on two systems, the bone, the kidney, and the intestine, and that is going to increase calcium. All right. So take note of that. So you can see what is happening again here. This is how calcium homeostasis works. So you can see what the the calcium, if it is low, parathyroid hormone is released, right? Parathyroid hormone is released. It is going to act on the kidney to cause reabsorption of calcium. So calcium still increases, right? And then what it also does on the kidney, it is to increase the production of 1,25 dihydrocholecalciferol, and that will come on the intestines to increase the absorption of calcium, and that increases calcium in blood. On the bone, parathyroid hormone will stimulate bone resorption, okay, and that increases the calcium in blood. And that is still also with the effect of 1,25 dihydrocholecalciferol. The opposite to parathyroid hormone is calcitonin, which is produced by the C cells of the thyroid gland. And what this guy does is that it inhibits bone reabsorption. Instead, it stimulates bone deposition. That is basically you forming bone, right? Making it dense. So we have already basically looked at this all. So on the bone, parathyroid hormone receptors are found on what we call the osteoblast. Just think of blast to build. These osteoblasts are the cells that are supposed to be building what? The bone. But look, parathyroid hormone is involved in breaking down the bone. All right? It is osteoclasts which break down the bone. But why is it that the receptors of the parathyroid hormone are found on the osteoblasts, which build instead of on the osteoclasts, which are supposed to break down the bone? So what happens is this: initially and transiently, just for a short period of time, parathyroid hormone is going to cause increase in bone formation by the direct action on the osteoblasts. And this brief action is a basis for the usefulness of intermittent synthetic parathyroid administration in the treatment of osteoporosis. Osteoporosis is a condition where I've got weak bones. So when you give like the parathyroid hormone as a drug, it will help in building the bone. But this action, remember, it is transient. Okay. So what happens that in a second and long lasting action on the osteo is going to be on the osteoclasts, and that is going to be in bone resorption, because the osteoclasts are the ones which resorb bone or break down bone. And this is regulated. Okay, this second action on the osteoclast is indirect and is mediated by cytokines. These cytokines are released by osteoblasts. So what happens when you have got low calcium? Parathyroid hormone is released. Parathyroid hormone is going to go and attach to its receptors on the osteoblasts. Osteoblasts are going to release cytokines. These cytokines will now go and stimulate the osteoclasts to start bone resorption. So that's the activity. And the overall effect of the parathyroid hormone, therefore, is to promote bone resorption, delivering both calcium and phosphate to extracellular fluid. Extracellular fluid, remember, blood is part of extracellular fluid. Okay. Hydroxyproline that is released from bone matrix is excreted in urine as you are getting to break down the bone. And then on the kidney, we already know the action. It is going to inhibit phosphate reabsorption. Instead, so phosphate reabsorption inhibition is happening in the proximal convoluted tubules, where I've got a sodium phosphate co-transporter. So instead of you absorbing, you're stopping that. So the phosphate is going to be released in urine. That's known as phosphaturia. phosphaturia. And this phosphate would have otherwise complex calcium, because if you relate this phosphate to be in blood, it is going to bind to calcium, and when it binds to calcium, the calcium is not going to be free, and so that is still appear as though you don't have calcium, because the calcium that is there is being bound to the phosphate. Okay, so excreting phosphate in urine allows the plasma ionized calcium concentration to increase. Parathyroid hormone also stimulates calcium reabsorption. Reabsorption is happening in the distal convoluted tube. Please take note. The phosphate is in the proximal. That's why you're inhibiting their reabsorption. But the calcium, the reabsorption is happening in the distal convoluted tubules. Okay, it will complement the increase in calcium concentration that results in the combination of bone reabsorption and the phosphaturia. In the small intestines, parathyroid hormone does not direct act on the small intestines, but it will do it indirectly. First, the parathyroid hormone is going to stimulate on the kidney. You have got what we call 1 alpha hydroxylase. This enzyme is the one that will be able to convert 25 hydroxycholecalciferol to 1,25 dihydroxycholecalciferol, which is the active form of the vitamin D. And then this active form of vitamin D now will go and act on the intestines to cause the absorption of calcium. All right. So what converts 25 hydroxycholecalciferol to 1,25 is hydroxylase. So this is what is happening. You can see here, it's a nice mechanism. So in our body, we have got 7 dihydrocholecalciferol. What happens that when we are in the sun, the UV light from the sun is going to convert the 7 dihydrocholecalciferol to cholecalciferol, which is vitamin D3. And then the cholecalciferol will be acted on by 25 hydroxylase found in the liver to be converted to 25 hydroxycholecalciferol, which is also known as the calcidio. This calcidio now be acted on by 1 alpha hydroxylase, which is produced by the kidney to be converted to 1,25 dihydroxycholecalciferol, which is also known as calcitriol, which is the active vitamin D. But what will stimulate the production or the activity of 1 alpha hydroxylase is parathyroid hormone and the reduction in the calcium in blood. Okay. If you have got a lot of calcium in blood, that is going to be able to inhibit. Okay. It will inhibit this enzyme. And when you have got a lot of the active vitamin D, remember it's a product, it also inhibit this. From food, we get what we call egocalciferol, which is D2. D3, we can also get it from natural foods. Okay, but still more, the egocalciferol can still be converted to 25 hydroxycholecalciferol by the same 25 hydroxylase, and then it will do the same function. So how is the calcium metabolism, the breakdown or the increase of calcium in blood and the decrease? There is approximately 1 kg of calcium in the human body, but majority of the calcium is actually found in the bone, where it forms what is known as hydroxyapatite crystals with phosphate. Okay, so bone will time and again undergo remodeling. Remodeling has to do with breaking down bone and then making it again. Okay, when there is a stress, remember when you are stressed, remember you are running, bone has to become much stronger, so you break it before you can form. Okay, so most of the calcium in bone is not freely exchangeable with extracellular fluid calcium. Calcium that is in bone, you don't easily take it back to what? To blood. Okay. So in addition to its mechanical role, bone is a reservoir for calcium. About 1% of calcium found in the skeletal system is freely exchangeable pool, and together with another 1% which is found in the periosteal space will make up the miscible pool of calcium. Okay, that is free at least. So calcium ion regulates a number of physiological and biological processes. It's involved in neuromuscular excitability, plasma membrane integrity and transport, blood clotting, Secretory processes. Calcium is actually a second messenger. Enzymatic reactions, release of hormones and transmitters. Calcium is very vital. Okay. So three forms of calcium, plasma calcium exists. So calcium in blood exists one complexed to organic acids. That's like 6% of calcium in blood is complex, is bound to organic acids. And then about 47% is bound to protein, specifically albumin. And then 47% is unbound, it is ionized, it is free. All right. Of course, these are other numbers from another book. Protein, which is the one which is bound, is like 40% to protein, that's albumin. And then you have got the ultrafiltrate, which is 60% of that. 10% is complexed to the organic acids or the anions. And then you have got 50%, which is free. Okay. So this again, the ionized or the unbound is like 47%. The concentration is about 1.1 to 1.3 millimoles per liter. So if the level falls significantly, this ionized or the free calcium, if the level falls, okay, then what happens? There is net excitatory effect on nerve. So that tells you that hypocalcemia excites the nerves, and then hyper excitability may develop result in hypocalcemia tetany, which is extensive spasms of skeletal muscle. So the skeletal muscles are now contracting too much. There's spasms, contractions like those. So a marked elevation may result in death because there's going to be muscle paralysis if there is hypercalcemia. Calcium ion and phosphate exist at or near their solubility product in plasma, meaning that they are more at equilibrium. Okay. Alteration in plasma protein concentration results in parallel change in total plasma calcium. In other words, remember calcium is attached to proteins, right? So if you reduce the proteins found in plasma, that is going to reduce or change the calcium concentration that you have. Like for example, in hypoalbuminemia, where I've got low albumin, it will result in a decrease in total plasma calcium. Remember, some of the calcium found in blood is bound to albumin. So if you have got little albumin, it means that that calcium that you're supposed to be on the albumin is not there. So there is a decrease in total plasma calcium. And when you have got hyperalbuminemia, there's going to be too much calcium. All right. So association of calcium with plasma protein is also dependent on pH. For example, acidosis, when you have got too many hydrogen ions, it favors the ionized form because albumin, hydrogen is positive, calcium is also positive. In other words, they are competing on binding to albumin. If you have got a lot of hydrogen, it will displace, it will remove the calcium from the albumin, and so the calcium is going to be free in the blood. It will increase in blood. If you have got alkalosis, low pH, it means you have got low hydrogen. So the calcium has got more chance to be on the albumin. And so that means that you're going to have little of it free in blood, right? So we already know again the effect of calcium. We already know the calcium metabolism, we already discussed it. Now let's talk about what is the pathophysiology. What can go wrong with the parathyroid hormone? There is hypoparathyroidism. This is just insufficient amount of parathyroid. Okay, and that is because the hormone is low because there is hypoparathyroidism. The parathyroid hormone is not working well, there is low function. So what happens then? There's going to be neuromuscular irritability. Remember, low calcium excites the neurons, and that is going to lead to tetany, these contractions. And the common causes of hypoparathyroidism can be after surgery, maybe the surgery of the thyroid, and maybe you removed these glands, or even the autoimmune destruction of the glands themselves, like you just form antibodies to fight against the glands. If there's also pseudo hypoparathyroidism, pseudo means false, so there is end organ resistant to biological active parathyroid hormone, meaning the gland itself is producing parathyroid hormone, okay, but then those glands that are supposed to use the parathyroid hormone They are not working, they are resisting. So that's pseudo hypoparathyroidism. And then hyperparathyroidism is excess production of parathyroid hormone. It can be maybe there's an adenoma, there's a tumor or a cancer of the parathyroid gland, or parathyroid hyperplasia. The parathyroid hormone has increased so much in size, or ectopic production of parathyroid hormone. Maybe there's another site where the parathyroid hormone is being produced. So all this can increase the parathyroid hormone. All right. And the what can you find when you have got an increase in parathyroid hormone? One, you are going to see an elevated serum ionized. There is going to be a lot of calcium in blood, which is ionized, and then we are also going to see a lot of parathyroid hormone. And then there's also going to be depressed serum phosphate level. Remember, when you have got a lot of parathyroid hormone, there's going to be excretion of phosphate, so it is going to be low in blood. Okay, so if you want to tell if someone has got hyperparathyroidism, you can get to do these tests. And then in long-standing cases, there's going to be extensive bone resorption. Remember, parathyroid hormone is involved in bone resorption. And then there also be problems with the kidney, like renal stones, nephrocalcinosis. There's also urinary tract infection, also a decrease in renal function. There can also be secondary hyperparathyroidism. Secondary may be seen in progressive renal failure. So there is a problem with the kidney. So what happens that the kidney cannot form calcitriol, which is 1,25 dihydroxycholecalciferol. So because you can't form this guy, it means that it can't go and act on the intestines to cause calcium absorption. And because of that, there's going to be secondary release of parathyroid hormone. Remember, you have got lead to absorption of calcium. So the body is going to interpret it. You have got low calcium. So what does the body do? It is going to tell the upper centers like this, the pituitary gland, and also the hypothalamus to say, can you give instructions to the thyroid, to the parathyroid gland, to release more of the parathyroid hormone to compensate for the low that is there. And so that is what leads to secondary hyperparathyroidism. The problem is in the kidney. Okay, so this table is just showing us in each one of the condition, the primary hyperthyroidism, what is the problem? So here, primary hyperparathyroid hormone is high. Okay, the 1,25 dihydrocholecalciferol is also high because the kidney is fine. Bone resorption is also fine. The concentration of phosphate in urine is also okay, but then the phosphate, serum phosphate, is going to be low because remember, when you have got a lot of thyroid hormone, it is going to decrease the phosphate in blood and then release it in urine. But calcium is going to be high. Okay. And then in surgical hypoparathyroidism, you have removed the thyroid gland. What does that tell you? It means that you're going to have low parathyroid hormone. You're going to have also low 1,25 dihydrocholecalciferol, low absorption of bone, resorption of bone, and low calcium in blood, but there's going to be high phosphate because you have got low parathyroid hormone. Okay. How about if you have got chronic renal failure, like the kidney has failed and it's been for a long period of time? What will happen is that the parathyroid hormone is going to be high because it low parathyroid hormone is going to send an instruction to the parathyroid gland to produce more of the hormone. So that's why it increases. But then there's a problem with the kidney, which is producing 1,25 dihydrocholecalciferol. So this guy is going to be low because there's a problem with the kidney that is supposed to produce heat. And then because of this 1,25 dihydrocholecalciferol being low, there's also going to be, you can see there's going to be osteomalacia because of the decrease in 1,25 dihydrocholecalciferol. There's going to be increased resorption. All right, there's going to be high resorption of bone. Remember, for resorption, what can happen is that the parathyroid hormone will simply act on the bone and then it will cause resorption. All right, so that's why there is osteomalacia, that weakness in the bone. And then the phosphate in urine is still going to be low, and those others. So for now, we are going to end here, and we're going to continue the rest in the next class.